Hello guys, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So myself, Murali Krishna, Bukkasamudram, I am having 21 plus years of teaching experience. So please join quickly and I will be teaching you the what are the coverage of syllabus in Finite Automata, and I will brief you about the Finite Automata in today's class in this summer crash series of theory of computation. So please all of you join quickly and mark your presence, please. I hope all of you are able to hear my voice. Am I audible and visible to every one of you? Just confirm me once. Yes. So this is about my brief profile. You can just have a look at my profile and I will continue the session. Yes, you can just say hi or hello. Everybody please. Yes, Gopal Verma. Good evening. I hope I am audible and visible to every one of you. Please confirm me once. Is my audio, video, everything is clear? Okay, that's great. Okay. So I hope every one of you have attended all my previous sessions of theory of computation. This summer crash course of theory of computation. Okay. So here in today's class, what to cover in finite automata, I'm going to discuss. Okay. So all of you please share this class information with your friends and also please do like this session. And please subscribe the channel if you have not yet subscribed it earlier. Okay, fine. Okay, now let us move. Yes, okay, thank you. Hi, PK Gupta. Good evening. Okay, so this is about my brief profile. You can just have a look. And as I already told you, myself, Murali Krishna Bokkasamudram, I am having 21 plus years of teaching experience. And I am a topper of NPTEL course in theory of computation. That's what I am teaching you right now. And I am certified as International Engineering Educator through ISRO certification program, and I have mentored more than 50,000 students across the country in different core areas of computer science and engineering. Those are theory of computation, operating systems, computer organization, computer networks, digital logic, and ICT. Okay, so this is about my brief profile. And so there is a GATE Rankers Monsoon series. It's a free course. Most important topics will be covered in electrical, electronics, and computer science. And we will be starting this from 10th July onwards. You can please do subscribe it and share with your friends. And we are having a national level scholarship test for GATE exam for getting a scholarship of up to 90% on 9th July at 9 a.m. Please register for it. And if you wanted to really prepare for GATE, now is the time to take a step towards success in GATE by getting maximum discount by appearing in this national level scholarship test and getting the good score. I will definitely give a chance for getting maximum up to 90% of our programs we are offering here for the GATE. Yes, Pradeep, good evening. I hope I am audible and visible to every one of you. Am I audible? Please confirm me once. Is my audio, video, everything is clear? Just confirm me once. Okay, fine. That's great. Okay, so now let me start the session. Yeah. Okay. Fine. And so finite automata. So actually, I will just brief you what is a finite automata and what are the topics you have to cover in the GATE examination point of view. And it is useful for all other competitive exams also. So finite automata is also called as finite state machine. Okay. Finite automata has no temporary storage and hence it cannot remember finite information, and with the help of finite control, which contains a state and transition only by storing the input on the input type. And finite automata accepts regular languages only. Okay, so whether input string is accepted or not, finite acceptor we can say accept a string if a string is in the given regular language, and it reject the string if the string is not in the regular language, because finite automata is an abstract machine for accepting the regular languages only. Non-regular languages cannot be recognized by the finite state machine. Okay, I hope everybody understood. If you give any input string, so finite acceptor will be verifying. So if it is going to final state in the machine, it will be accepting, and that string is present in the language corresponding. And if it is not going to final state, it will be rejecting, and that string will be in the non-final state. Hope everybody understood. Now coming to finite transducer and produces an output for a given input. So this is the input string, and from the input alphabet, and output string will be generated based on the input. Okay, so configuration of finite automata. So graphical it is like this. So we can have an input tape like this, and on the input tape we can have different input symbols. And finite control can control the total operation. So there is a read-write header, and only reading information is taken place, and header moves on to the right side. For example, you are having a strings like A, B, B, something like this. Okay, on the right hand side, it is infinite, and we start with the initial state Q naught. Okay, and it keep on moving till you get epsilon. That means till ending of the string. When the string is ended, if the resulting state is final, string will be accepted. Resulting state is a non-final, string will be rejected. So these are the two criteria. So this is a graphical representation of finite state machine. So this is input tape. It contains a string over the given input alphabet. Okay, just in order to just imaginary representation of this finite state machine will be like this. Okay, I hope everybody is able to hear my voice. Is it clear? Okay, so that is the criteria. Now coming to read write header, only performs read operation, no write operation in the finite automata. In push down automata also only reading, but we use the stack. But in Turing machine, we have a capability of moving the header in both the directions. So read head is a pointer which reads one input symbol at the time and moves to the next symbol. It always moves on to the right side. Okay, and then configuration, it is like finite control contains set of finite states like this. Set of finite states and a transition function to take an action based on the control state and input symbol scan. So usually this finite state machine can be represented with set of states Q and set of inputs sigma. Delta is a transition function, Q naught is initial state, and F is the set of finite states. So these are the 5 entities. That's why this machine is also called as the quintuple machine. So tuple is nothing but entity. So there are 5 entities: finite set of states and finite inputs and transition function, initial state and set of final states, and F is the subset of set of states. Okay, so that is the criteria. And for every string, the finite control starts from an initial state. If the string is valid, finite control reaches to the final state. If string is invalid, it reaches to non-final. For instance, you can take an example. And before I give an example, so there are different equivalent machines in finite automata. So deterministic finite automata DFA, non-deterministic finite automata NFA, and epsilon NFA, all are equivalent. So all these power is the same power. All the machines will have a same power. And in our syllabus, you have to cover NFA epsilon moves, NFA you have to cover, DFA you have to cover. So only thing is, for a given regular language, we can show by means of a regular expression. Regular expression can be easily converted to NFA epsilon moves. Okay, epsilon NFA we can convert into NFA without epsilons, and NFA we can convert into DFA. So this is the sequence, and DFA we can minimize and we can implement. Okay, so these finite automata and regular languages are used in the lexical analysis phase of compilation process. Okay, and here if you consider, for example, just a moment. So if we consider all these 3 finite automata accept the same class of languages called as regular languages. The class of languages are same, that's why this is called same power. We are having a same power. And every DFA is also a special case of NFA, and we can convert every NFA to DFA. NFA can be converted into a DFA using some subset construction. So for everything there is a procedure. So that procedure we have to follow. We can convert from one machine to another machine. Even epsilon NFA also can be converted to NFA. NFA also can be converted to DFA. Okay, so that is the criteria. Actually, regular expression is possible only for regular languages. It is a simplified format of all the strings of regular language that we can convert directly into epsilon NFA using some rules. Okay, and epsilon NFA you can convert into NFA without epsilons. and NFA we can convert into DFA. So our intention is to construct the DFA deterministic, but direct construction of DFA is a bit difficult. But in GATE exam point of view or all other competitive exams, you have to practice a direct construction of DFA only. But as there is NFA and epsilon NFA also in the syllabus, we have to study the representation of epsilon NFA and NFA, interconversions and everything. Okay. And if you have any doubt regarding the amount of coverage, okay, please ask me. I will let you know, because I'm not going in detail about the discussion of any subject here in detail. Just briefly I'm describing, but the main concept is most of you might be having some doubts regarding how much content you should cover in finite automata in the GATE examination point of view. So please try to make use of this session for asking me and for interacting with me, and I will let you know what exactly you should cover. Okay, so as far as these three topics are concerned, what you can do: epsilon NFA, a representation you learn, and a construction also you should learn, and a conversion from epsilon NFA to NFA you should learn, and conversion from NFA to DFA you should learn, DFA to regular expression. So these are the things you should cover as far as these three equivalences are concerned. Yes, compiler design is construction of TOC. No, it is not construction of TOC. Yeah, continuation. Exactly, you are right. Sorry, I read wrong. So Pradeep, yes, it is compiler design. After the theory of computation only, you should start the compiler design for better understanding. Okay, because in compilation there are different phases, right? Like lexical analysis, syntax analysis, semantic analysis, etc. Code generation, code optimization. In the lexical analysis, finite automata concepts, regular languages, and regular expressions, all those things are used. And in the syntax analysis, pushdown automata, context-free language concepts, okay, pushdown automata and balanced parentheses, all these things are used. Okay, na? Yes. I hope. Yes, Tinku Kumar Gupta. So yes, now you can ask me whatever the doubts you have in the coverage of syllabus, and also please don't forget to share the class information with your friends, and also please do like the session. And if you are not yet done subscription, please do subscribe the channel, as we are providing a lot of free content. Okay, so please try to make use of this. And coming to representation of finite automata, as I already told you briefly, finite automata we can represent using 5 entities: set of states, inputs, transition, function, and initial state Q0, and F is the set of final states. So Q is a finite set of states, and sigma is input alphabet contains finite number of inputs. Delta is a transition function defined over transition of finite automata for states and inputs. Okay, and this delta is delta is from Q cross sigma to Q. What do you mean by Q cross sigma to Q? Q is any state in the set of states, and sigma is any input in the set of inputs, and this will give you resulting state. So state and input. So state and input is the actually these are the two arguments in a delta, and Q is a resulting state. And Q0 is also a part of set of states, so it indicates the initial symbol, initial position of a machine, that is called initial state. Okay, and F is a set of final states. You may have multiple final states also, and which is a part of subset of set of states. And state transition diagram I will show like this. Every state represented by a circle. Okay, and for initial state, a circle is associated with an arrow, indicate it is a starting state. Final state is represented by double circles, and every state is connected with transitions associated with input. So the diagram will be like this. So in this diagram, so Q0 is a state, it is a non-final state. Q1 is a final state, double circle. This arrow indicates, Q0 and arrow indicates it is a starting state, and this indicates self-loop. So what are the inputs here? Set of states in this machine are Q0 comma Q1, and the set of inputs in this machine are X comma Y, X comma Y. Okay, and delta. So delta is like this. Delta is a transition function. So for input X and input Y, okay, for a Q0 on X, it goes to Q1, and Q0 on Y, it goes to Q0, and Q1 on X, it goes to Q1. Q1 on Y, it goes to Q0. So like this, we can have the transitions for the states and inputs. Hope everybody understood. And Q sigma delta Q naught is the initial state, and set of final states is F. So that is a Q1. Q1 is the set of final states. Okay, that is a state transition diagram for this one. And so states and I'll explain here. And state transition table containing rows and columns. Every row corresponding to the state of DFA, and every column is input, as I told you. Input associated with an arrow. This is like this. So sometimes now we show the circle for a final state and star for initial state. Okay, and language accepted by the finite automata. What do you mean by language accepted by the finite automata? L of M means language accepted by machine M here. So what type of strings are accepted in the language? Strings like X provided if transition of Q0 on X is in final state. So what do you mean by transition of Q0 on X final state? For example, we're having two states Q0 and Q1, where Q1 is the final state, and we are having inputs like this. So B and B, and A's are having a self loop like this. Let us suppose. Now let us suppose I am taking X is equal to string like A, B, B, A, let us suppose. So transition of, so X will be accepted provided transition of Q0 on A, B, B, A should go to the final state. What is the Q0 on A? Q0 on A goes to Q0 only. So it is a transition of Q0. On the tape, input tape, BBA is remaining. So Q0 on BBA. And Q0 on B. Q0 on B goes to Q1. So it's a transition of Q1 BA. And Q1 on B, it goes to Q0. So transition of Q0 on A. So Q0 on A goes to again Q0 only. So Q0 does not belongs to final. So that means it is not accepted. If you take other string, for example, I am taking X is equal to something like BA. So it is accepted. So transition of Q0 on BA. So Q0 on B is Q1. So transition of Q1 on A, also Q1. So Q1 belongs to final state. So BA is accepted. So odd number of B's are accepted. Any number of A's. Total number of B's must be odd. So that is what the language accepts by the finite automata. If you have any doubt, you could ask me. So strings will be accepted only when there is a path from initial state to final state. For example, A, B, B, A. From initial state A, B, B, A, it is going to non-final. B, A, it is going to final. So every string we have to begin from initial state. Is it clear? And still, if you have a doubt, please ask me. And don't hesitate to ask your doubt. And let us move on to the next. So example I have given. And the types of finite automata like acceptors and transducer. Acceptor means a machine will either recognize a language or reject a language, something like that. Only accepting and going to final state it is accepted, going to non-final it is rejecting. Transducer means it will produce output actually. In response to input, some output also will be produced. So that is like Moore and Mealy machines are examples of that. Okay. So Moore machine and Mealy machine, you might have heard about it. Okay. So types of finite automata is acceptor, and also transducer. Okay. So finite automata, these are the things. Now I will give you a clear picture regarding how much you have to cover in the syllabus. Okay. So finite automata is finite acceptor like finite automata without output, and finite transducer, finite automata with output. So without output we have DFA, non-deterministic finite automata, and epsilon NFA. And transducer like finite automata producing output, Moore machine and Mealy machine. So in this, what you are going to cover, I am telling you. Please observe carefully. So as far as the finite automata is concerned, so construction of finite automata for regular languages you should learn. As many regular languages as possible you should try to cover. Okay. And also you practice directly construction of DFAs without going through all the procedures. Individually procedures also you should learn, and also direct construction of DFAs also you should practice. Okay, based on the language. When a language is given, a regular language is given, immediately you should be able to construct a DFA. That much practice is required if you wanted to excel in the GATE exam. Okay, nearly 200 to 300 languages if you practice, it will become easy for you actually. Any type of language you can construct if it is a regular language. And also interconversion like NFA to DFA, all those previous gate problems we can cover. And in the Moore and Mealy machines, how to construct a Moore machine for certain languages, how to construct a Mealy machine for certain languages. And in addition to that, you will also learn about conversion from Moore machine to Mealy machine and Mealy machine to Moore machine. And especially in DFA, minimization of DFA also you should try, like how to minimize the number of states in the DFA. Okay, and what is the criteria, and how to compare the two DFAs, whether they are accepting same language or not. All those things should be covered here. Okay. In addition to that, you can go through the Myhill-Narrowed theorem for accepting for finding a language for a machine, and to find out equivalence classes. Okay. So this is how the coverage should be. And if you have still any doubt, please ask me, and I'm here to help you. Do you have any doubt regarding the coverage in the finite automata? And most of the time, DFA will be given, language will be asked. Or regular expression will be given, DFA will be asked. Or DFA will be given, regular expression will be asked. Okay, or NFA will be given, equivalent DFA will be asked. And majority of the cases, what will be the minimum number of states required for so and so language to accept in the DFA? This type of questions are asked earlier. And even number of reachable states for a certain state and input combinations in NFA, the type of questions are also asked. Okay, you can practice of the type of questions. Okay, and it is all about regular languages. Actually, finite automata is about regular language. Before the finite automata construction, if you can study the construction of regular expressions, then you can see the essence of that very easily, and always you can easily understand. Okay, and that is the criteria actually. And I wanted to give you one more example here. So generally, if you wanted to construct a DFA easily, there are different tricks actually. For instance, I wanted to construct a DFA something like, let us suppose a plus b whole star ab. I wanted to construct a DFA directly. Normally, if you take an NFA, it is very simple. NFA, whenever the star is there, we give a self loop, and we give A to one state and B to one state, and going to final. And before AB, we can have any combination of A's and B's. That is NFA. But DFA, deterministic finite automata, DFA, and A plus B whole star AB means we can have AB is a minimum string, AAB, okay, and BAB, okay, and AB. So this type of string, any string that is ending with AB is required. So a DFA construction, direct construction you should practice. That's what I am telling you. So first of all, you have to verify minimum string AB. So we require 3 states. AB is accepted. Some of the string we have to verify without missing. AB we should verify. Any number of A's followed by AB, any number of B's followed by AB, and AB followed by AB. You have to check without missing. So AB is verified. Any number of A's means if you give A here, it becomes an FA. You have to give A here, so that AAB also will come. Okay, and any number of A's. BAB, any number of B's, we can give a self loop. AB or BAB like this, and AB, A we can give back to this. And finally, on the final state, on input B, you can go to initial state, because if you give a self loop, it will end with BB. If you give back to the middle state, again there is a chance of ending with BB. That's why if you give to this, there is no chance of ending with BB. So AB accepted, BAB accepted, AAB accepted, AB accepted, AB accepted. So this type of string. So this is the perfect DFA for all combination of A's and B's ending with AB. For all combination of A's and B's ending with AB. Hope everybody understood this. Is it clear? Everybody understood this? Yeah. And if not, please do let me know. And please share the class information with your friends. Okay. And like that, we can construct the DFA. And if you have any specific doubt, you could ask me now. And if there were no doubts, just I will conclude the session. And And tomorrow also we are having a session, and please attend the session at 10:15. I will update in the Telegram group. I hope all of you have joined the Telegram group. Otherwise, in the comment box, I will share the Telegram group link and you people can join. And even after the class is finished, I will continue answering your questions in the comment box. Please don't forget. And finally, if you are not yet done subscription, please do subscribe, and also tell your friends do the subscription of the channel. Yeah, tomorrow also Pradeep class is there at 10:15. We are having a class. Okay, so please attend at 10:15. Thank you so much. Thank you, Anandal. Have a good night. See you all. Bye bye.